Hello everyone, welcome back to this online class. Today I want us to look at how to integrate 1 over 2 sec x minus 1 with respect to x. So what we do here is to use the t method of substitution. So we are going to say let t be equal to tan x over 2. So this is our substitution. We need to find the corresponding differential. So we are differentiating t with respect to x. So we write dt dx is the same as 1 over 2 sec squared of x over 2, which can also be written as 1 over 2 into 1 plus tan squared of x over 2. And this can also be written as 1 over 2 1 plus t squared, because tan x over 2 is t. So tan x over 2 then we square, so that will give us t squared. So therefore, make dx the subject. So we'll have dx is equals to 2 dt over 1 plus t squared. So that's another substitution that we need to make. We also need to know what is sec x in terms of t. So I'm going to use this substitution for t is equals to tan x over 2 to come up with a right angle triangle of this form. Right angle triangle. Our angle is x over 2. Opposite is t. Adjacent is 1. So katoa. So when you use Pythagoras theorem, you get the hypotenuse to be the square root of 1 plus t squared. So remember, secant of x is the same as 1 over cos x. So I must find cos x. Then from there, we take the reciprocal to get sec x. So from our triangle, it is clear that sine x over 2, that is opposite t over hypotenuse, the square root of 1 plus t squared. We also know from the triangle that cosine of x over 2 is the same as 1 over the square root of 1 plus t squared. So how do I find cos x? So cosine of x is the same as cosine of x over 2 plus x over 2. That's cos a plus b, where a is equals to b. So this will give us cos squared of x over 2 minus sine squared of x over 2. And we know those in terms of t. So when I replace, you square cos x over 2, that will give us, let me write it, 1 over the square root of 1 plus t squared. This one should be squared, then subtract t over the square root of 1 plus t squared. This also squared. So when you simplify this, we are going to get 1 minus t squared over 1 plus t squared. So that is cos x. So with this, you can now find sec x. So therefore, sec x the same as 1 over cos x. So the reciprocal, that will give us 1 plus t squared over 1 minus t squared. That is sec x. So back to our integral. Let's work out the denominator, which is 2 sec x minus 1. So what will that give us? We need 2 times sec x, then minus 1. That's the same as 2 times 1 plus t squared over 1 minus t squared, then minus 1, which you can write as 2 plus 2t squared over 1 minus t squared minus 1 over 1. So when you take the LCM, we are going to get 1 minus t squared. That's our LCM. So here we'll have 2 plus 2t squared, then minus, of course, I can put this in bracket, minus 1 minus t squared. So when you open the bracket in the numerator, you're going to get 2 plus 2t squared minus 1 plus t squared. Denominator, we have 1 minus t squared. So that if we simplify this, numerator should now be able to give us 3t squared plus 1 over our denominator, that is 1 minus t squared. So that is 2 sec x minus 1. But what do we have as the integrand? 1 over 2 sec x minus 1. So we need to take the reciprocal on both sides. The reciprocal of what we have found. So you can say hence 1 over 2 sec x minus 1 is now the same as 1 minus t squared over 3t squared plus 1. So this is what we need to integrate. Remember, it was with respect to x, so, and we also know dx in terms of t. So back to our integral. Our integral will now become, let me write it. So hence, or therefore, the integral of 1 over 2 sec x minus 1 dx, that is the same as the integral of 1 minus t squared, everything over 3t squared plus 1 dx, the same as 2 dt over 1 plus t squared. And so this can be written as 2 outside 1 minus t squared in the numerator. Denominator, we have 3t squared plus 1 times 1 plus t squared dt. So then you need to ask yourself, how do we integrate this kind of a function where denominator is a product of two quadratic factors? So when you have such kind of a product in the denominator, the best thing is to use partial fraction decomposition. So let's decompose our integrand using partial fraction. So to do that, you're going to say let 1 minus t squared over 3t squared plus 1 times 1 plus t squared be equal to a times t plus b over 3t squared plus 1. Remember, I told you that when the denominator is linear, the numerator must be, when the denominator is linear, the numerator is constant. When the denominator is quadratic factor, the numerator must be linear. So we also add plus ct plus d over 1 plus t squared. So when you multiply both sides of this equation by the LCM, we are going to get this. you're going to get AT plus B times 1 plus T squared plus CT plus D times 3T squared plus 1. So that should give us 1 minus T squared. So this should be equal to 1 minus T squared. That equation we can open or simply we can expand the left-hand side of that equation so that we get this. If you expand the left-hand side, you're going to get this, or AT plus B plus still A T cubed plus B plus BT squared. I have multiplied the first term. Then the next term, that will give us 3C T cubed plus CT plus 3D T squared plus D is equals to 1 minus T squared. And then I can collect the like terms on the left-hand side so that I have coefficients of T cubed, to give us A plus 3C, then T cubed. Then look at the coefficients of T squared. I can see this B T squared and another 3D T squared. So we have plus B plus 3D. That is the coefficient of T squared. Then coefficient of T, we have A and we have C. So you can write plus A plus C. This is multiplying T. Then the constant terms, we have B and D. So we say plus B plus D. That should give us 1 minus T squared. So the next thing, you equate the corresponding coefficients. So let's look at coefficients of T cubed. We are going to get A plus 3C should give us 0. There's no T cubed on the right-hand side. So this one is equation 1. What about coefficients of T squared? Coefficients of T squared, it will be B plus 3D equal to -1. The -1 here on the right-hand side. So call this equation Roman 2. Then coefficients of T, that is A plus C. That should be 0 because we don't have T on the right-hand side. So this is equation 3. And lastly, the constant terms for the coefficient of T raised to 0. Remember, anything raised to 0 is 1. Or I can just write constant terms. That is B plus D should give us 1. 1 is the constant on the right-hand side. So this is equation 4. So we need to solve these 4 equations simultaneously. If you look at equation 1 and equation 3, they involve A and C. Also, equation 2 and 4 involve B and D. So we can treat 1 and 3 separately. We solve them to get A and C. you solve these two. Look at equation 1 and equation 3. If I take equation 1 minus 3 minus equation 3, what will we get? It is a minus a, that is 0. 3c minus c is 2c. So when we solve 1 and 3, we get this. Let me write. I'm taking 1 minus 3. What will it give us? It will give us 2c is equals to 0, which means c is equals to 0. So therefore, if I substitute in equation 1, because I know c is 0, even a will be equal to 0. Now let's again solve the other two, equation Roman 2 and Roman 4. So now I'm considering Roman 2 minus Roman 4. What will it give us? When we subtract 2 minus 4, that will give us 2d equals to negative 2, which means d is equals to negative 1. So when I substitute d is negative 1 in equation Roman 4 and make b the subject, we are going to get b is equals to 2. So that's what we have. We have now found the constants a, b, c, and d. So we go back to our partial fraction, the partial fractions, so that we say therefore 1 minus t squared over 3t squared plus 1 times 1 plus t squared can now be written as a is 0, so that is 0t plus b, so b is 2, so that is 2 over 3t squared plus 1. Then I have this negative 1, so this will be minus 1 over 1 plus t squared. So this is what we need to integrate with respect to t. Go back to our integral. Look at our integral. This is what we need to integrate with respect to t, having decomposed the integrand. So I'll rewrite the integral. We just say therefore, we now needed 2 times the integral of 1 minus t squared over 3t squared plus 1. This is multiplying 1 plus t squared dt. That's simply the same as 2 times the integral of 2 over 3t squared plus 1 minus 1 over 1 plus t squared dt. So this can be written further as, I want to split them, so I'll have 4 times the integral of 1 over 3t squared plus 1 dt, and the other one we have minus 2 times the integral of 1 over 1 plus t squared dt. And finally, you need to use trigonometric substitution to be able to find or to evaluate those two integrals. In the first integral, here you're going to say, let t be equal to 1 over root 3, 1 over root 3 tan theta. In the other integral, you're going to say let t be equal to tan theta. So let's start with the first integral. when t is equals to 1 over root 3 tan theta, what do you think is dt? Dt will be equal to 1 over root 3 sec squared theta d theta for the first integral, and this other one dt will be sec squared theta d theta. So this integral, when we substitute t, we are going to get this. We are going to get 4 times the integral of 1 over 3 times t squared. T squared is the same as 1 over 3 tan squared theta, that's t squared. Then I can see plus 1. Then there was dt, which is 1 over root 3 sec squared theta d theta. So you see here 3 will cancel with the 3. So it's like we have tan squared theta plus 1, which is the same as sec squared theta. So the whole of this, let me use a different color. The whole of this will cancel with the sec squared theta to give us 4 times the integral of 1 over root 3 d theta, which is simply 4 over root 3 theta. And we know theta, we can get it from here. If you make theta the subject, you get theta is tan inverse of root 3t. So this is 4 over root 3 tan inverse of root 3t. Let's also evaluate the second integral. What will it give us? I can highlight it. Let me bracket this one. This is what we want to evaluate, and we now know the substitution. So when we evaluate this, it will give us this integral. So that is equals to 2 times the integral of 1 over 1 plus t squared. T squared, that will give us tan squared theta, and dt is the same as sec squared theta d theta. And you see 1 plus tan squared theta is the same as sec squared theta. So this is the same as the integral. Of course, there's 2 outside of 1 d theta, which is simply equal to 2 theta. And you can make theta the subject in the second integral. Let me just circle where we made the substitution. If you make theta the subject here, it will be tan inverse of t. So theta is tan inverse of t. So this thing here can now be written as is equals to 2 tan inverse of t. So now we know the solution for this integral. So that our answer here, see, this is what you are integrating. This is what you are integrating. And we decomposed and found those 2 integrals, which we have now found their solutions. So when we substitute back into the original integral, that is this one, we are going to get the solution to be equal to, the first integral gave us 4 over root 3 tan inverse of root 3 times t. The other integral gave us, because it is negative, so negative 2 tan inverse of t. Then don't forget to write a constant c of integration. And because our answer is in terms of t, but the original integral was in terms of x, I need to replace t. So you put, check where we define t, we said t is equals to tan x over 2. So let us substitute that one. And so it will be able to give us, that will give us 4 over root 3 tan inverse of root 3 tan x over 2, then minus 2 tan inverse of t, which is tan x over 2, then plus c. But take note, tan inverse of tan, this one here, tan inverse of tan x over 2 is the same as x over 2. So it's like we have 2 times x over 2, which is simply x. Remember, tan inverse of tan theta is the same as theta. Sine inverse of sine theta is the same as theta, etc. So this will now give us 4 over root 3 tan inverse of root 3 tan x over 2 minus x plus a constant c. So this is our solution for the given integral. Thank you for watching. Next time we look at other forms of integrals. Bye-bye.